Welcome back to this recruiting guide. We have already talked about a primer on recruiting generally, as well as how to recruit for venture capital, how to recruit for product management minus interviews, which is what we're going to cover today, which include the phone screen / behavioral, written assignment, product design, business strategy, estimation, as well as technical questions with examples from the amazing Nick.
Hello. So I was previously an APM intern and then a full-time APM over at Google. And just as a disclaimer, of course, all of my opinions are mine alone and they do not reflect the views or beliefs of my current or former employer. The fun legal stuff out of the way, I'd also love to call out that I am by no means a perfect interviewee. I don't promise to have perfect or even great answers to these questions, but I do at least hope that they are helpful.
And they will be. Starting off with two general tips that we have. The first is when it comes to who to practice with, pick friends who are really good at that specific type of question. So for example, if you're doing a technical question, you might want to practice with a great engineering friend, or a product question with a PM who's already in a role that you want, or a behavioral question, maybe with someone who's just like really eloquent generally. Don't find a general interviewer to ask you all types of questions, because that just isn't particularly effective. Also, when it comes to practicing, you want to practice in front of a mirror or recorded, because you probably do weird things with your hands and face and whatnot. And you always want to practice like it's the real thing. So for example, time it, do it, like write it, speak out loud, do it as if it was the real interview, because oftentimes people will say to themselves, oh, I'll do this differently during the interview, and that's just not true.
Yeah, that's a great tip to kind of augment that. The thing that we recommend is make sure that you do your homework. So make sure you're reading the books that are out there. Specifically, I cannot recommend enough read Cracking the PM Interview. That's just kind of a required reading. Everybody else will have read it, so might as well kind of catch up there. And then, of course, there's some other books out there, one of which is called Decode and Conquer, which I think is a great read for PM interviews. And then there's also Thinking Fast and Slow. Also a solid read. Many PMs or aspiring PMs will have read both or all three.
So first we're going to talk about phone screen / behavioral questions. Now, when it comes to the phone screen, they are mostly looking for red flags. In other words, they're just trying to figure out, are you a reasonably good human being? Do you have some inkling of product sense? So for example, a question that is very likely to be asked of you at some point is, what is your favorite product, or what is your least favorite product, something along those lines. And you should just have an answer that you are familiar with. This would actually be much longer than this, but you can say something to the effect of, oh, one of my favorite products is Notion, as part of their target user demographic, which is essentially like young, millennial, tech-forward people. One of my favorite features is that they really templatize using keywords. So people who are a little bit techy tend to understand keywords. So if you type in a / and then a very obvious name for a template like calendar in Notion, it'll show you a template of a calendar. Now, the reason why you actually have to prepare these questions is because a lot of behavioral questions are misleading, because they sound like anyone can answer them with whatever you want. Like that type of question sounds like, oh, I'm just going to rant about my favorite product, or I'm going to rant about my least favorite product. But providing structure in practice is really going to help you stand out for the interview.
Speaking of standout things, one of the things that you probably submitted when you applied to this role or whatever job you're interviewing for was your resume, which should be full of all sorts of cool things that you did. And you want to make sure that you're able to speak intelligently about every item on your resume, because behavioral and phone screens are the places where they'll probably ask you at least one or two things about the items on your resume. And then the other thing to remember is that you'll probably get a couple of consistent questions that ask you about just who you are and your own experience. So another tip that we have is make sure that you prepare 5 stories on yourself, and don't memorize these, be normal. Make sure that you have a sense of 5 different things in your life that you're able to talk to. And they should be your strengths. You're probably going to get asked about your strengths at some point. Your weaknesses, probably going to get asked about those too. And then a time that you were a leader, so sometime that you showcase leadership capabilities. A time where you handled conflict, that could be interpersonal or intellectual conflict. And then, of course, a time that you were a PM or PM-like. So if you'll recall, PMs are data and outcome driven. So anytime that you were being outcome or data driven, where you're getting great outcomes to happen, that's a great thing for that last category of story.
Second, let's go over the written assignment. Now note, it does vary company by company, but it does tend to follow the standard format of design blah product for blah user group. So for example, design a dishwasher for college students. Now, often you'll get a couple days to do it. They say that you should only spend like a few hours on it. Many people spend more than that if the deadline is outside of that. But yeah, that tends to be the structure of the written assignment.
Awesome. I think something to consider whenever you're writing a written assignment is people aren't paid to read what you wrote. So be concise, be as short as possible, be very structured in how you actually approach things, because the whole point of the written assignment is to assess how well you communicate in a written medium, whether that's presentation or a report. Or a deck. Well, that's what I mean by presentation,
Okay.
but just deck or presentation.
Yeah, you're right.
And so when you write these written assignments, it is really helpful to go and get an example or a couple of examples of what the kind of document you've been asked to write looks like. You can just go online, Google like product presentation if you've been tasked with doing a deck or presentation. And the reason that this is important is it not only helps you kind of get inspiration of how you want to structure stuff, but it also helps your reader pattern match to things that they have already become familiar with. So we recommend for doing written assignments.
3, moving on to the product design question. This is a very meaty part of the PM interview because you are doing PMing stuff. Now, there are 2 canonical ways to be asked this. The first I'd say is the most canonical, which is design product X for Y user group. For example, design cameras for kids, something like that. Another type of problem that you might get is here's a behavior that a user group is displaying. How would you change the product to change that behavior? So for example, this is just an example, maybe people spend 20 minutes on the checkout page on Shopify before checking out. Why is that? How would you change that? Now, the product design questions are much like a lot of PM stuff, it sounds deceptively easy. I don't know if that's the right way to say it, but essentially, when you get asked this question, it's very easy to just spew opinions like, oh, I would change this button, or I think this, or I would do this. But it's not about you, it's about you being empathetic and understanding your user and using logic and structure when providing your answer.
Yeah, I mean, it's ultimately about your user. And that's the job of a PM, and that's what your kind of whole thing in your mind should be, who is my user? Now, that being said, there's some advice to kind of help you bring that out. So one piece of advice that we have is essentially practice a structure, and you want to really nail this down to the point that you essentially sound robotic in how you actually answer these questions. Now, the reason for that is whatever you practice, that's how you're going to actually interview, but just like less well. So you actually want to add in naturality or making yourself sound more natural onto that structure so that you don't sound like a robot in your interview, but it'll help you quite a bit in being very efficient and succinct in your answers.
I think the robotic piece is around signposting your structure.
Yeah.
So essentially you use the same structure every single time, you signpost it well, which means you announce what you're doing before you do it.
Yeah, exactly. And then the next piece of advice that we have is, well, what is that structure? So the structure that I like to use, but you can always find your own, is I like to ask clarifying questions. That's step 1. So just define the problem, really narrow down the scope, understand exactly what your interviewer is asking of you. Step 2 is, okay, I have the scope, so now who is my user? Who am I actually talking about? And I like to come up with about 3 groups, if I can, of 3 potential types of user that I'm talking about, and then kind of narrow it down to one of just kind of based on logic and reasoning. My third piece of how I actually do this structure is then what are the 2 users groups like problems? So what problems does this user face? I again like to enumerate 3 and then pick one as kind of the biggest pain point. And then 4, come up with a solution. How do you actually solve those problems? If you can solve all 3, but of course definitely solve the main one that you picked. And then number 5 is metrics. How do you know if you were successful? How are you going to actually measure that you were able to solve your users' problems mentioned in the previous steps? So that's my 5-piece structure. Now, at the end of all of this, you'll have created a bunch of assumptions, or you'll have used a bunch of assumptions, you'll have listed a bunch of stuff out, you probably have asked a bunch of questions. So when you're creating those assumptions, be very, very explicit on them. List them all out, write them down if you have a piece of paper near you, and do the best that you can to be as explicit as possible and call them out to your interviewer. And then when questioning anything, when you're trying to ask questions, use that as an opportunity to reveal what you know. So when you ask point blank questions, you're just like, what do I do here? Should I assume that this is in the US? It's fine and it's reasonable, and your interviewer will probably answer those questions, but you aren't necessarily revealing all the cool stuff that you have learned.
You sound like you don't know what you're doing and asking for help.
you might sound lost or confused.
Yeah.
And that's not ideal. So instead, with like maybe a question of like which location or region am I talking about, you can say, well, I know that the United States market is very different from the EU market, which is very different from like the Chinese market. And so I'm most familiar with the American market. I'm actually going to target the US market in this product design question. Does that sound reasonable to you? And now I'm still asking for guidance. You might say, no, I'd actually prefer you talked about like the EU market or the Chinese market. But they might say, yeah, that makes sense. That's very reasonable. Either way, I've now revealed that there's different pieces of information here, just a little bit. You might want to delve into a little bit more when you actually ask those kinds of questions.
Okay, so to concretize all of this stuff, we're actually going to go straight into an example.
Awesome.
So I have been tasked with a product design question of design a nightstand for kids. Please excuse my absolutely horrendous handwriting. I have been criticized for this my entire life, and now will be criticized for it on YouTube. All right, so design a nightstand for kids. So the first question I want to ask you is this going to be kind of generic kids, anyone from the age of 1 to 18, or can we kind of subdivide that? I think the most reasonable way to subdivide this is into kind of elementary, middle, and high school. I also think that middle and high schoolers, since they're pretty similar to adults as far as nightstands go, are probably well served. So I'm actually going to specify maybe elementary school kids. So kind of kids in the age range from, 6 to 10 or so. How does that sound? Sound reasonable? Awesome. All right. So my core user here is going to be, as we just kind of clarified, we're going to talk about kids age range equals elementary school. And then as far as nightstands go, I'm going to just kind of use the canonical understanding of a nightstand, the thing next to a bed. Often there are 2 of them if you have enough space. Often adults will use them to store just kind of like sleep mask, books, reading materials, glasses of water, or milk at night. Does that sound about right to you?
Sounds great.
Awesome. Alrighty, so if my users are elementary school kids, then these are pretty young kids. They aren't really people who are necessarily even reading yet, although at the end of elementary school, they probably read. So what I'm actually going to kind of care about here is what problems do they have? Something that I actually want to point out though is in kind of this users section, it's important to remember that parents actually will be buying. So parents equal the buyer, but kids essentially equal the actual user. So that's something else for us to remember is problems here might include some parental problems. So for example, I think that parents might want to govern kind of light usage by their kids, especially elementary school kids. And then they also probably, especially with those really young kids, want to be able to kind of wind down or like maybe bedtime like activities, like bedtime stories, just bedtime reading, whatever it is to kind of help their kids settle down and get to sleep. So they need kind of a way to interact with those bedtime activities, maybe store them. And then I think maybe more generally, this is actually just storage is the actual problem here. And I think maybe a third problem here is we don't want the kind of kids to be hurt by anything. We don't want anything to be too complex. So like simple, child safe, but at the same time, there's a kind of a tension here where a lot of child safe stuff looks very cartoonish, and we want to balance that with, I guess, aesthetic. That's going to be tough to spell. Pleasing. And that's because remember, parents are our buyers. They may not care too much about the aesthetics of their children's room, but this is something important. And that actually reminds me a little bit of kind of an asterisk here is something we should consider as kind of price point or the user's kind of income level that we're targeting here. I'm going to say for now, maybe it won't matter too much, but it's just something for us to note. So I'm going to start that assumption a little bit just so I remember about it. Great, so we have a couple of different problems here. The reason I frame out light is I think that it's not necessarily a core issue that we want to deal with nightstands, but you'll see a lot of nightstands contain some sort of lamp. So even in the adult world, we talk about using lights in nightstands, but I do think that it's a kind of secondary issue, something that if nightstands came with lights that parents could control, that might make it easier for them to make sure their kids are actually going to sleep. As far as winding down bedtime activities and storage effectively, I think that's kind of our primary use case is really just how do we actually store bedtime activities. I'm going to say that light thing is kind of our second one. And then the simple, child safe, aesthetically pleasing, I think that's kind of a third concern and or marketing. So I'm going to label them in priority order there. The actual solutions that I want to go into from this set of problems, though, we're going to have to explore. So I think the biggest solution that is kind of most obvious is just give a bunch of storage and attach a light to it. So kind of like the easy solution is essentially like a basket plus soft light. And so this basket should be big enough to contain kind of like children's books, maybe some stuffed animals, etc. So I think that's essentially the easiest, most straightforward thing. We can use some sort of aesthetic wicker basket, get it to match someone's aesthetic. We could offer different styles of basket, kind of metal, wood, wicker, maybe cloth. All of which, I guess the metal and wood might not be as safe for kids, so that's something we might want to consider. That might let us target different parts of the kind of kids market, but really parents who are buying for different children. But I would say that we'll offer a couple of different versions of that product. It gives us some flexibility if we use kind of a flat basket with a soft light. The other thing here is in this solution, we aren't really considering like different price points, but the kind of basket soft light design gives us we can kind of play around with which price points we want to actually target. And I think that having a soft light, maybe we want to make sure that this actually is like attached to the bedstand or the nightstand, but can be moved. So maybe we want to make that a movable soft light, kind of one of those like snake chain extension cord thingies. And then we want to have it be controlled. Let's make this kind of a smart control by like parents, controllable by parent phone. And I think by doing this, we're kind of implicitly going to go back to that price point piece of making it a little bit more expensive, kind of a premium style nightstand. So premium style, this is also for parents that are targeting elementary school. They're trying to get a nightstand for their elementary school kids. I don't know about you guys, but my siblings actually shared a room when they were growing up. So I think if you're at kind of that mid or premium tier price point, it's reasonable to also add in the cost for making it controllable by parent phone. That sound about right to you?
Sounds great.
Cool. So given all of this, we have kind of an easy go-to solution, and we can come back and kind of ideate a little bit later, but for the sake of time, I'm actually going to talk a little bit about how we would actually measure success. So metrics that I want to talk about are going to be, there's kind of obviously sales, right? So how much sales volume is going to be just like number of nightstands sold. And let's say, I don't know, annually, but any time, unit of time really works. I think it might be interesting to segment that by location, specifically locality to elementary school, and then middle and high schools. And so there's kind of a hypothesis here that this might actually be a useful product for more than just kids. It might not even be a useful product for kids, and we would want to kind of see that. I think using locality to elementary, middle, and high schools is kind of a simple way of saying, okay, if this is truly useful for elementary schools, there should actually be a lot more sales annually if you're closer to an elementary school. I don't necessarily know if I have too many other metrics. We could always collect some qualitative data by using surveys, everyone's least favorite metric. But I think it could be useful here, especially if we wanted to get some like incident reports of like, are there any accidents? How well are we actually solving this child safe problem? And we could also look at online reviews. And so this would also help us with that simple child safe piece. The storage bit, I guess we kind of solve implicitly by just tossing a basket, and it's an easy solution, gives you a bunch of storage. All right, so I think that's kind of the summary here, but just to recap, we're targeting elementary school kids in this question. We have to remember that parents are the buyer, which kind of drove this option 3 and really problem 2 here. And then kids are a user. And then option one really, or problem one really reflects just like the primary use case. We're using this to store stuff for wind down and bedtime. Light is kind of a secondary piece of that, and it's something that parents want to control, and it's our hypothesis that we have. And then problem number 3 here is really just making sure it's aesthetically pleasing. Our solution is just very straightforward. Make a basket, toss a soft light on that, make that controllable by the parent's phone. And then, of course, we're going to measure stuff with how much we actually are able to sell this thing, and then segment it by location just to test some other hypotheses. We'll collect some qualitative data on that as well. But yeah, that would be my kind of go-to solution.
Okay, number 4 is business strategy questions. They fall into 2 types of questions. The first are why questions. The second is how questions. Under why, examples are like, should company X launch Y products? So for example, should Facebook launch a logistics arm? Should Amazon enter the short form video market? Why or why not? In terms of how questions, this is more on execution. So they might say, this company wants to enter this region, or this company wants to do this user group, or this company wants to launch this product. How would you do it? Essentially, those are the types of questions you might want to look at. Now, it is really critical that you actually know the company that you're interviewing for and how they make money when it comes to the business strategy questions. And this is very deceiving in tech. For example, Google might look like a search company, but really it's an advertisement company. Or Amazon might look like a retailer, but really it's an infrastructure company. What are other examples? Microsoft looks like a hardware company, but they're really an enterprise, like OS company.
Licensing the software. And
Yeah.
then I guess like Facebook's another canonical, like looks like a social media company. Turns
It's
out it's
ads.
ads. There's a lot of companies that are kind of like that.
Yeah.
And also actually beyond knowing just the company, you actually want to know a lot of the kind of detailed workings of like the products of a company.
Their main products.
Yeah, and so I think if you look at like a company like Google, there's like search and ads, and that's great, but there's some really clever stuff that Google has done. So being able to display ads to people is really important. So you see acquisitions like YouTube, where it's like, okay, we were able to do search ads with search, so now let's do video ads with YouTube. And then you're like, oh, well, how do we actually get even more people onto kind of the internet looking at our ads? Well, you launch a browser, so you get Chrome, and you can control their web searches from the browser onward. Then you're like, actually, even better, let's make Chrome the default browser for an OS. Let's go get Android. And now you have a whole operating system that gets Chrome onto people.
Okay, I was going to say, I feel like Nick you don't need to know at that level because Nick actually worked at Google and he worked on Chrome and he worked on, so he understands these inner workings. But for example, when I was interviewing for Facebook, I looked into like Facebook dating, like less common features, but still core features that you are expected to understand.
Or you might want to know like high level, like Microsoft, they've acquired, LinkedIn, GitHub, and the reason that they would do that is because, and Minecraft, which is kind of bizarre. And the reason they might do that is Minecraft is kind of for kids, people are gaming, but they're getting into this kind of logical mindset. Then they're starting to code, so they're going to put their code on GitHub, and they're going to be networking professionally, and that's going to be on LinkedIn. And now you own kind of a whole stack of someone's career. So there's kind of interesting things there that are still high level, but know the products. And then, of course, the last thing in business strategy is how do you actually answer these? So the advice that we give, again, use a structure. So you're going to clarify the question, you're going to figure out who your users are, you're going to figure out their problems, and then, of course, you're going to try and solve those problems. But you're going to come at it from more like a business strategy lens. So your solution should be reflective of like what's the business's goals. That's where tying back into like knowing the business and its products is actually pretty important. It helps you be a little bit more creative and reasonable in your solution all at once. And then, of course, how do you measure success? Never forget that piece. And then the last piece of advice that we have here is there's some kind of common strategies that you'll see show up. And as you look at a bunch of businesses and trying to understand how they work, you'll see these strategies. But there's 3 that we'd love to mention. So 1, 3-sided marketplaces. That's where you get essentially just 3 different parts. There's the actual marketplace, and then there's one side and the other trying to sell to each other. And the actual marketplace is really secretly not just the platform, it's usually ads. So like YouTube, great example of a 3-sided marketplace. There's the content creators, that's one side. There's the content consumers, that's us, that's the other side. And then there's, of course, the advertisers, the ones that try to make money off of it. Or the most money off of it. So 3-sided marketplace is one structure that you should definitely kind of understand. A second structure that you want to understand is network effects. So that's where you get a lot of social media giants, Facebook, Twitter. What they're doing is essentially the more of your friends that are on the network, the better the network is for you. So then you'll want to join the network. And now for one of your friends, it's even better for them. Network effects are super common as a structure. And then the last structure that we actually want to talk about is essentially vertical integration and ecosystem building. The biggest example of this is Apple. So take control of the whole stack from production or ideation to production to every layer of that production, and then build out an interoperable ecosystem around it.
These are essentially all business strategies that if you understand, you'll start seeing them in a variety of places. But to actually put this onto paper, we're going to now go into an example.
All right, I have been asked to tell us, should Google build a new product for billboard monetization? I'm going to run out of room, so we're going to just put a question there, and I didn't finish that word. So, should Google build a new product for billboard monetization? Before I dive into just saying yes or no, I think it's important for us to actually explore a little bit about what the kind of options out there might look like and whether or not Google might have some sort of unique advantage. So let's start by just really clarifying what do we actually mean here by kind of new product. I'm going to assume that it's reasonable for Google, because of the amount of capital that they have access to and of course their digital infrastructure, to consider either or both of a like software-based product or hardware-based kind of infrastructural project. Does that make sense?
Yes.
Great. So we're going to leave ourselves open. This could be software and or infra/hardware. So great. That's a good thing for us to remember. Something else that I'm going to talk about is there's many different places billboards show up. You could even argue that kind of like the big ads in an airport, for example, are billboards. But I'm going to go with kind of the canonical understanding of billboards as kind of like city, like freeway in like cities or freeways in cities, billboards. So the billboards that are visible from cars, they often contain kind of canonical old style ads. I think this makes sense because it gives us a really high throughput audience. There's just a lot of people going in and out of cities. And I think it's kind of the canonical understanding of billboards. But did you mean anything else by billboard?
Nope, that sounds good.
Perfect. Great. So these are, I think, enough for me to start to kind of think about it. Oh, and locality-wise, I'm actually going to talk about the United States. That's the market I know the best, and I think also a great market for thinking about billboards. But let me know if you have any other localities you want me to consider. So US markets, cities and freeways, kind of billboards, could be software or infra. So the actual users we want to talk about here, I think it's important to remember that, of course, there's the people looking at the billboards, but I think the primary user here is advertisers. So this is people who want to do marketing. They're trying to do marketing, and they want to make money by getting people to buy their stuff on their ads or engage with them through their ads. There's more complexity to that though. So marketing can actually be used for a bunch of stuff, but I'm going to target kind of like I want people to take action from this ad and buy stuff sort of advertising. There is also the like users who actually, I was going to say click the ads, but who see the ads and actually then go to try and use the thing. So we're going to call those like users. I guess that's kind of redundant, but users. And what I mean by this is kind of people, like people in cars who see the billboard. And then, yeah, let's just go with that for now. There might be some other users. You could also consider like the people who you're building the billboards around, etc. But we're just going to talk about these two. I think that the biggest problems for these people, these users, can really be broken down into attribution on the advertiser's front. So how effective was my billboard? And then I think also there's a usability problem. And I'm using this as like a high level encapsulation of essentially, I can't remember what was on the billboard. So if I'm the kind of user category up there, my abbreviations are a disaster. If I'm this user group up here, then not being able to remember what was on the billboard is a problem for me. Like, let's say I actually wanted to go and click the link that I saw and buy that product. It's also kind of a secondary problem for these advertisers. If they can't get their billboard to be memorable, then it's effectively useless to them. But primarily attribution. Can I actually say in like a marketing meeting, like our billboards are generating this much revenue? And I think that that's important. So what we're going to do is we're going to say that this is our primary problem, attribution, because that's what we actually care about as our primary user. And then, of course, usability affects both user groups. And let's see if we can come up with a solution for this. So is there a solution that Google is uniquely positioned to develop? I think there's a kind of immediate right off the bat solution, which is kind of Google can build infra for digital billboards and work with advertisers to, I'm just going to call them whatever, I'm going to spell the whole thing, and can work with advertisers to create unique and memorable links. So there's kind of a key assumption here, which is that they're creating links. This is for link-based ads. If you're trying to get a phone number out there, this might not be as useful. And there might be other things where you're actually just trying to get like brand awareness. This is kind of less important. But essentially, I think Google is actually in a pretty good position to essentially use a bunch of money to then go out and invest in a bunch of infrastructure for digital billboards. And then they essentially just have companies pay to get that digital billboard real estate. And then they can work directly with the advertisers. Google's very familiar with how to provide products to advertisers to create really interesting links. And the reason I say unique and memorable is essentially you could create links like green giraffe, like your company /green giraffe. And that might be a really easy link to remember if you're like, Sentry.io/green giraffe. That's very simple. But green giraffe was only a unique combination shown on like Monday from 3 to 5 p.m. In San Francisco on a particular freeway, 103 or something. Well, now we can actually do attribution. So I think this solution actually really helps us with attribution. Usability-wise, that's kind of funny. I might remember green giraffe or whatever people actually ended up coming up with. I think this solution might work really well for us. There's kind of an interesting caveat here, although in the interest of time, I'm not really going to go into it. But there's kind of like an addition here of Google is able to do. Essentially, they own Maps and Waze, and I think technically Alphabet owns them or whatever. But Maps and Waze allow us to do some really cool stuff with cross-checking traffic patterns, and I think there's some really, really cool stuff there that we could do, just being able to track people's locations and see what ads they saw, or at least guess at what ads they were exposed to. But I'm not going to be able to get really into that. And then I think based on this solution, I'm able to answer the actual question, which is I would argue, yes, Google should definitely do this now because they're in a position to build infra. They can just do that and they can test it out in some pilot cities. And then they're definitely in a position to utilize their unique connection and ownership of Maps and Waze to get some other cool data in there that they honestly probably already get. And then metrics. I think a really interesting metric here is, well, there's a boring metric of ads served / purchased. So just how many ads are people actually buying on these things? But even more interesting, I think, is hit rate. So a really cool metric for us here is just how successful are these ads? And this is part of the attribution thing. So this is useful to advertisers, but it's useful to Google too. And I think that it's really helpful to actually understand where the hit rate is essentially ads. I don't really know how to call this, but kind of clicked, but they're not actually clicked, I guess, obviously, divided by the canonical term is impressions, but ads seen. And also because these are digital billboards, it's actually very easy for Google to swap out, A/B test, do whatever they like with this infrastructure to kind of verify or essentially optimize this hit rate. And that should help with ads served, which might be the KPI for Google. So this is the solution that I would kind of go with or recommend. I think, yes, Google should build a new product for billboard monetization.
Okay, so the fifth type of question in your interview process that we are talking about is estimation questions. Ooh, everybody's favorites. Actually, everybody hates this question type. Anyways, there are 2 categories for this as well. Canonically, you see how many blah fit into blah. Like that's a type of estimation question. So for example, how many apples fit into a bathtub? How many Apple products are sold in the US daily? Or you might see some sort of market sizing question, which is, I don't know, how many people in India use the bus every day? Or how many TVs do you think are sold to young parents? Anyways, okay, so those are the types of questions, and we have 3 tips for how to answer this before we go into the structure. When it comes to the first tip, it's that you actually don't need to get the question super accurate, in that the whole purpose of this, secretly, is not for you to get to the right answer. It's about communicating with structure and getting to approximately the right answer. A lot of people think these types of questions are stupid. I personally do, as someone who really struggles with basic math sometimes. But they're actually not, because you'll find that when you use logic, you'll get within an order of magnitude, or even more so than that. You'll get within like twice double, I would say, very, very frequently. So that's tip number 1. Tip number 2 is that you should have a baseline set of information, like actual facts that you can use. So for example, the population of the US is approximately 330 million, 320 million.
And actually, that's a good clarification, is 330 million is a really difficult number here, even though 320 million is not that far off. And the reason is 320, very easily divisible. I can divide that by 2, I can divide it by 4, I can divide it by 8. 330, not so much. I can divide by 3 or 11, and that's kind of tough.
So that leads us to actually very well to tip number 3, which is you need to practice writing down basic math, speaking while you're writing down that basic math, and just various mental math tricks. So for example, when you're talking about populations, you can often bucket them into quarters, because that's just 25%. And when you choose numbers, you can just round up or down to something that's a very easy number. So those numbers are often, multiples of 2, 4, 10, 5, things like that.
It's not 60, it's 64. Now it's power of 2, easy to divide out and multiply. It's not 103, it's 100. Like things that make your life easier.
Yeah.
Really gonna help.
And it's going to get you to approximate the same answer.
Yeah. You'll actually get to see me mess that up a bunch later, because talking while writing while also thinking through the math is
hard.
Tough. But to make that easier, we do have a structure that we, of course, like to use. So again, clarifying questions. You're going to start by just making sure you understand what is actually being asked of you. Cannot emphasize this enough. Try and figure out what people are asking. Then this deviates a little bit from like define the user, which we've used in our couple other questions here. The next piece that we're actually going to do is we're going to define our assumptions. So we're going to just start to actually lay out, like, I'm going to assume this. Maybe you say, I'm going to assume the US has 320 million people. It's not quite right. Like, there's some actual number out there, but it's close enough. So you want to list out your assumptions, be pretty clear on them, and you want to really quickly get to like what assumptions matter based on your clarifying of the question being asked. Once you've done that, then you're going to decide on a style of approach. I generally pick kind of like a build it backwards sort of approach, or kind of like a top-down kind of approach. And what I mean by that is like there's a number you need to get to. So then I can just kind of work backwards from that of like, okay, well, what thing do I know that'll get me part of the way there? And
essentially, like, how do I break down this number into smaller pieces?
Right, exactly. And then eventually you'll get to a point where you actually have a set of numbers that you're like, they're in my assumptions. So now I can multiply everything out and I'm done. There's another style of approach that I'm not as good at, but I know some people who are, where you essentially just say, well, based on my assumptions, I'm going to just start kind of combining them to get to my answer. And they'll add in assumptions, kind of layering them in as they try and get closer to their answer. So this is bottoms
up. So let's say you make 4 baseline assumptions. You find the numbers that fill up those assumptions. You multiply everything together and you get your answer.
Yeah. It's not always multiplication, I guess.
Yeah,
but we use that
or
as
you add it or whatever. Yeah.
So that's another piece of this. And once you've done all of that, you've gotten to your number, you might think you're done. But remember, the last thing is always just check yourself. Check your answer. Make sure that you actually make sense. So these are kind of like these tests or heuristics to try and say, okay, is this over or under? You want to be able to articulate to your interviewer, like, this estimate is likely going to be an overestimate or an underestimate.
Because I made this assumption here.
Exactly. And point back to your assumptions. And this is often a point where you're like, oh, wait, that assumption was wrong. It's okay to call that out. Just say, hey, I was actually wrong on this. Here's why. Make sure you're explaining this.
If you have time, you can fix it. If you don't worry about it.
Exactly. It's just try and be reasonable.
Great. So now let's go into an example of this.
Awesome.
I have been tasked with how many schools in USA. Alrighty. So before I dive straight into this question, I think it's reasonable to omit some categories of school that I think were probably low volume. So I'm going to kind of omit like home schools, maybe pre-professional schools. I'm actually going to also omit universities because I feel like school to me is more of just like elementary, middle, and high school. But let me know if I'm omitting and cutting too many things here, and I can add them back in.
That sounds good.
Perfect. Alrighty, so we're going to just talk about elementary, middle school, and high school. So the way that I think we should break this down is let's just start with just how many people do we think are even that age. So I'm going to say that, we want to kind of target folks in kind of the 1 to 20 years old bucket. I know that overcounts by a decent amount, but we're going to use that as just kind of our heuristic, because if we say that there's 320 million people in the United States, then we can actually break this down into 4 main buckets. So we're going to, okay, these are very small buckets, but you'll get the point. We're going to break this down into 4 buckets of kind of 1 to 20, okay, 21 to 40, 41 to 60, and 61 to 80. And this is just kind of my canonical breakdown, but I think this makes sense. These are kind of the age groups we want to target. And then we're going to just really deal with this 1 to 20 age group. So that gives us 80 million people in that bucket. The question then becomes, how do those 80 million people or elementary, middle, and high school students actually divide up amongst elementary, middle, and high schools? So I think we can actually say, well, there's 5 grades in elementary school, there's 3 grades in middle school, and then there's 4 grades in high school for a total of 12 grades, right? Yeah. And then what we want to be able to do is proportionally, what is that? So let's start from forward backward because that's easy. 4 divided by 12, that's going to be 1/3. Sorry, you're going to hear my math get really wonky. And then 3 over 12, that's going to be 1/4. 5 over 12 is like roughly 1/2. That's not quite true though. So 1/3, 1/4, this is actually 0.33, 0.25. We add those up, we get 0.58. And then that means that this one is 0.42. So we'll just kind of write those down and use them later. Alrighty, so we have roughly these proportions, and what we want to do is we can actually just go ahead and kind of set up an equation for this. So we're going to do like 0.4, let's say, by elementary school number plus 0.25 by middle school number plus 0.33 by high school number, and that's going to give us 80 million. Is that going to give us 80 million? That doesn't quite make sense. So I think that's actually the wrong direction here, because now I have 3 variables and that doesn't really help me out too much. So I'm going to try a different strategy. I'm going to actually say, oh right, this is the proportion of the breakdown. We're just going to multiply things out. So what we want to actually do is we're going to just say, okay, 0.42 is close enough to 0.4, so we're going to call that 2 over 5 times 80 million is going to give us 80 divided by 5, I think, is 16. Is that true? Yeah, that's close. Yeah, that's correct. 16 times 2, we get 32. So this is 32 million. Then we're going to do the middle school one. So we get 1 over 4 times 80 million, which gives us 20 million. Love that clean math. And now we get 1/3, because of course we do, times 80 million, which is going to be, it's between these two, so it's like 20, I'd say 26-ish million. That seems right. So now that we have all of these numbers, what do we do with them? Well, we need to estimate how many people on average are in each category of school. So I'm going to use some anecdata here, and that's just going to be my best bet. So I'm going to guess at kind of how many people I think are in each category, and we're going to go from there. So I think in my elementary school, there were roughly, let's call it 400 people. In my middle school, let's say that there were, 500 people, or I don't know, that's probably right, like 5-ish. And then in my high school, let's call it 2,000 people, and that's about right. So now we actually need to do out that math. What do all these numbers become? And I am going to struggle a little bit here because I have not practiced my arithmetic. So we're going to use a scratch pad up here. Let's say 32, 1, 2, 3, 4, 5, 6 divided by 400. Cross out 2 zeros, and now 32 over 4 is 8. So we have 8, 1, 2, 3, 4 zeros, so we have 80K. Then we're going to do 20 over 500, so 20, 1, 2, 3, 4, 5, 6 over 500. It should be same order of magnitude, so just kind of our check there. 2 zeros are gone. 20 divided by 5 is 4, and now we have 40K right there. And we're going to do our last one. I'm actually going to circle these so I don't lose them. And then we have 26, 1, 2, 3, 4, 5, 6 over 2,000. That's kind of cool. We get 3 out there, 3 out there, and then 26 divided by 2 is 13. So we have 13,000 or 13K there. Great, so that's how many schools we have. We have 80K, and then we have 40K, and then we have 13K. That seems honestly a little bit low, but okay, we're gonna now add those all together, and we're gonna end up with 120 plus 13 is 133,000 schools in the US. So now we actually have to go check all of this. I starred some things here, and I'm gonna just try and see, I guess I didn't star this, bad habit on my end, but we should check that number too. So we have 2 numbers that we wanna actually check. The anecdata here, I honestly think is actually probably a little bit high. I think 400, 500, and 2,000 is probably a little overcounting. So that means that we're actually going to end up with numbers that are a little bit too low. So the 32, 20, and 26 are being divided by something too big. So this is actually going to be a little bit of an undercount, which makes sense. My intuition was like 133K is a little bit too few. So we're actually going to want to go up. And then the 80 million over here, I think this is an overcount because, well, we were overcounting like 1 through 5 and then 18 through 20. So there's some overcount there of, let's call it 8 over 20, which is equal to 4 over 10 or 40%. But maybe those two kind of equal out, and maybe we'll just call it 133K altogether. So I'm going to call that my final answer as this estimation question. Cool. So I think something that's kind of fun is we might as well just kind of check, I guess. So let's go ahead and see what this might look like. So I'm going to pull up Safari, no judgment here. And let's see if how many, not how much coffee, elementary schools in the US. We'll start there. Oh, that's cool. So using this totally random, not fact-checked website that may or may not be correct, it does look like we are actually reasonably close. Looks like the actual answer, according to a completely random website, is roughly 130K. So not too far off, not too shabby for a complete guess. All right, that's kind of nifty, just like a fun way to see like where you order a magnitude correct. But you definitely don't have to be. The logic here is what you're really after.
Okay, so finally we are going to cover technical interviews, which is number 6, part of the interview process. If you're curious whether PMs have to be technical or not, we actually answered this in our previous video. Also, Nick is going to cover most of the section because he's actually run a lot of technical interviews now, in addition to doing a lot of them himself, so he has the best information. But first, in terms of the type of difficulty of questions, people often get really, really scared about technical interviews, but they are a practicable skill. And for PM interviews, for college students, they are usually at the level of LeetCode Easy or HackerRank Easy.
Yep, yeah, that sounds about right. So don't be too daunted, you can learn it.
Yep.
The kind of main things to know for them are going to be kind of your combinatorics, strings, lists, linked lists, things like that. Some basic algorithms, so like maybe your BFS, your DFS, merge sort. And then the actual data structures that you're probably going to need to know. I mentioned kind of lists and linked lists, but also kind of like basic graphs. Facebook loves graphs, so you're going to get those. And then like dictionaries, arrays, I guess I mentioned lists.
Queues, stacks.
Queues and stacks, thank you. Just kind of your normal.
What type of question would be too hard, or do you think is at a level that you probably won't need to know for PM interviews?
I think if someone was like, oh, they gave you some sort of problem where the answer was like Dijkstra's.
Yeah,
I think that's probably a
thinking
little
that
bit
too.
too advanced. Or like a red-black tree is the solution data structure-wise. That's probably too much.
So in other words, LeetCode easy, HackerRank easy,
Something.
basic data structures and algorithms.
Yeah, exactly. And when you go to answer these questions, you're still going to want to answer them essentially how a software engineer would answer them. So the structure that you follow is, again, clarifying questions. You got to figure that stuff out. So for example, with like lists, you're going to ask like, what do I do in a singleton list or an empty list? Are there duplicates in my list? Is my list already sorted? There's just a series of basic clarifying questions that you really need to make sure you cover. Then once you've really understood the problem, you understand what's being asked of you, then you're going to move on to just kind of blueprinting out or strategizing your approach. So this is really just going to be kind of a verbal, you might write some notes and take some stuff down, but it's like, here's how I'm going to tackle the problem. And you're going to talk that through with your interviewer. Listen to them when they give you hints. A lot of interviewers are going to ask leading questions. They're going to try and help you out. Listen to their advice. They're trying to help you. And then once you've kind of come to a like, yeah, this seems like the right approach with your interviewer, plan your code. So pseudocode, it sounds like you're spending too much time planning. I promise it'll save you in the long run because it gives your interviewer a chance to essentially save you. So when you're doing out your plan, it's pseudocoding out. If you're not super familiar with that, then I would go ahead and Google that. But it's essentially just like not quite code, but it's a logical set of instructions or an algorithm that you're going to plan out. And then code. And go ahead and just kind of implement that pseudocode. I like to use Python because effectively your pseudocode is essentially code. You don't have to be usually syntax
Use
perfect.
the language that you're most familiar with.
Yeah, just don't pick a random language, pick one that you like. And then once you've done all of that, go ahead and actually check your answer. Walk through an example, check the logic, go back through your code and make sure it makes sense. Make sure that you're kind of checking common error cases, essentially button it up a little bit. And
Wait, common error cases such as zeros, negative numbers.
Yeah. Bad numbers, bad
single
inputs,
nodes, something like that, yeah.
Weird stuff that could come through, logic errors that could be introduced, whatever might have you. And then the last thing is, if you have the ability to, I would recommend pointing out like time complexity. So that's where you get like your big O notation, usually like O of n log n, O of n squared. These are kind of the things you're going to throw around. Be able to talk about that. And if you have time at the end, then see if you can come up with an optimization. Often your first approach is not perfect. Usually it's actually not perfect. That's okay. Even if you can't actually implement the optimization, pointing it out to your interviewer and being able to say, hey, this is how I would switch from O of n squared to O of n log n. I would introduce a sort up at the top. That's great, and that's something that can definitely show a little bit more technical abilities.
A really good tip is to go for correctness before going for efficiency.
Yes.
You'd rather give the brute force solution, recognize how you can optimize it, and then optimize it if you have time, rather than just giving a completely wrong answer. Because
Yes.
a completely wrong answer will probably get you rejected, but the correct but slow answer might get you very, very far.
It's a decent shot.
Yeah.
Oh, and one other thing to call out, especially with like modern Python, this is kind of a really specific tip, is if you have the ability to use type annotations when you're doing that kind of planning phase, when you're writing the pseudocode, I would recommend that. It'll save you a bunch of issues later, and it helps your interviewer really understand that you understand what you're writing. Really weirdly specific, but I actually do think that helps quite a bit.
Awesome. Okay, to concretize this, we are going to go straight into an example.
Example time.
So we have a technical question for us. So let's see. The question that was posed was K-sum, right? I think. So I think the question as posed is like, given a list of numbers and K and some number K, find pair whose sum is closest to K. Great. Alrighty, so first off, we just want to clarify that list. So are these numbers kind of integers, floating point numbers, real imaginary numbers? I'm going to say probably integer, floating point, does it matter?
Integer is fine.
Great. All right, so we're going to work with integers. Positive, negative, 0, all of the above.
Yes.
Yes?
Can be all of them.
Okay, so can be less than 0. It's just like this is in the set of, I guess, that all integers. Something like that. That's going to mean for me. Sorry, math people, I might be wrong there. All right, cool. So that's the numbers that we're worried about, and lists. So can the list have duplicates?
Yes.
Okay, can have dupes. Is it sorted when it comes into me?
No.
Great, not sorted. And then am I ever going to have to handle like empty list or singleton list?
No.
Okay, so no
Actually, yes.
Oh, okay. All right, so
Singleton and
empty plus singleton are problems I might have to worry about. Cool, and those should be kind of problems for me because we're looking for a pair of numbers. So if it's singleton or empty, then we definitely can't find a pair. So we'll have to just define the behavior there. Cool. Then I think I understand enough here. Is k guaranteed to be an integer, like the numbers in the list? An integer could be positive, negative, or 0.
Yes.
Great. So this applies to the list and k. Awesome. So the actual plan or approach that I want to take here is I think I have this list. It seems to me like what I would want to do is sort this list. So my high level approach is I'm going to sort the list, which I can do in O of n log n, where n is the number of numbers in the list. And then I am going to, what I want to be able to do is find the pair whose sum is closest to k. So I'm going to start with just a pair of numbers. Maybe let's say like I and j are kind of pointers, or I guess we're going to probably deal with this in Python. They just kind of indicate different indices in the list. So I'm going to do the first and second. And since this is a sorted list, I can essentially bring this first one up if I am less than k. So if their sum is less than k, I can take this j and kind of integrate or increment it upward, going into each next thing in this array, which will always be greater. And then I can get us as close to k as possible. That actually doesn't seem quite right. Oh, you know what? I'm going to put this at the end, not there. And now I know that I have the kind of maximum difference here. And if the sum is greater than k, then I'm going to decrement the top one. And if the sum is less than k, I'm going to increment the bottom one. And then this will allow me to kind of get through the list and eventually find at least as close to k as I can get. I stop either if I find k or if I and j are right next to one another. Great. So this approach kind of makes sense to me. Does that sound like a reasonable approach to you?
Yes.
Perfect. All right. So the pseudocode that I'm going to follow is I'm going to define a function called ksum. It takes in a list and an integer, or an integer k. And so the pseudocode I'm going to follow here is, I always forget this, but it's something like lst.sorted. I think that does an in-place sort. One of them is in place. It's either .sort or .sorted. I don't really remember. We're going to call this an in-place sort. So that's going to do an in-place sort. And then I'm going to say I equals 0. And then we're going to just say j equals, the length of the list minus 1. So that puts us at the two different ends there. And then we're just going to say, like, while I is less than j, does that work? I'm always worried about like an off by 1, but let's say that that's true. While I is less than j, if list at I plus list at j is equal to k, then we just want to return. Do you want me to return the pair of numbers whose sum is closest, or sorry, the pair of the numbers or the pair of their indices?
The pair of numbers.
Great. Okay, so we can just return list at I, and there's an extra list index here, comma list at j. So I'm actually going to return, I probably should have started with this, but I'm actually just going to return a tuple. So if they're not equal to k, then we just check everything else. So we could do an elif, but it doesn't really matter because that if it executes is a return. So if lst of I plus lst of j is greater than k, so we know it's not equal to. If it's greater than k, then the j piece needs to go down 1. So we're going to then just say j minus equals 1. Else, we now know that it is less than k, so what we want to do is I plus equals 1. And then we should keep iterating. I think that's correct. And then essentially, what we want to do is return list at I, comma list at j. So there's a couple of things. I'm not actually fully convinced of that, but we're going to say that that's like the right logic of the plan that we actually just did. This is the pseudocode. Now this is Python, so the pseudocode is actually essentially the code. I might have a syntax error here or there. So the thing that we want to check is, does this actually work? So I think it's valid to check an example. And then there's, of course, like error handling. So like any of these weird error cases, empty or singleton list, which we know we have to care about. I think a reasonable expected behavior for empty or singleton is to return none, or a tuple of none. So at least the broad type is correct. Does that make sense to you?
That sounds good.
Great. Okay, so what we would do in there is if lang of list is less than 2, we will return a tuple of none, none. So that allows us to handle both of those error cases. It's not sorted, but we sort it, and then there are potential duplicates. I don't think that'll matter here. So there might be a duplicate. That actually reminds me, there might be duplicates that are equally close to k. Does it matter which pair I return that's equally close to k?
Return the first one.
Just any of them?
Yeah.
Okay.
You return any of them.
Okay, cool. So I can just return any of these so that doesn't affect the answer. Great. So now let's walk through an example. Let's just do kind of like a 1, 2, 3, and k equals, I don't know, 3. So 3 is the actual answer, and 4 is pretty close to 3, so we might get some interesting behavior here. So I'm going to walk through this a little bit. So I starts at 0, which is here, and then j starts at 3, or starts at 2, which is pointing here. And then essentially what we want to do is, this is sorted, so we know it's in order. And then while I is less than j, which is true, if it's equal to k, which is not, so 1 plus 3 is 4, which is greater than k. So then the second one, we take j and decrement it by 1. So now we come back around and we say, okay, is this equal to k? It is, so we return 1 and 2, which is correct. What if, so that example worked out totally fine. Let's see if we can get to an example where it never actually equals k, but it's pretty close. So we can do that pretty simply. Let's just do 2, 4, 6, whose sums will always be even, and then pick an odd number, 5. So I think 2 and 6 is 8, 4 and 6 is 10. Oh, wait, we can kind of figure that out algorithmically. So 2 and 4 is the closest number, that's 6. It's only one greater than 5. We will never actually equal 5, so let's see if our code actually works. So we again start at 2 and 6. And then while I is less than j, which is true, is it equal to 5? No. So then is it greater than 5? 2 plus 6 is 8. It is greater than 5, so we decrement j. Now we have 2 and 4. So while I is less than j, I is less than j. So now we get here and we've caught a bug. So now we actually have the issue where, because I is less than j, j is only I plus 1. If we decrement it again, which is what we would do, we're going to then end up coinciding. So now we're going to have 2 and 2, and 2 and 2 is actually equal to 4, and now we're going to run into like some sort of weird behavior. So we actually have to catch that. So the problem is that essentially in this code, a kind of easy patch that we could use is, we could say I doesn't always have to be less than just j. I actually has to be less than j minus 1. That might be an easy patch, because that would have caught this case. If I had to be less than j minus 1, well, on this second pass, they're right next to one another, so we know that we should have broken. It actually kind of logically makes more sense to insert this here, I think, where if I is equal to j minus 1, we then just break out of our loop. So that would catch this case, because now these two are next to one another, so it'll break. And yeah, that actually makes sense, because there shouldn't really be a case where that isn't our problem. Cool. Okay, I think this is correct code. I might be missing some. I'm sure I'm missing something obvious, but this seems pretty reasonable. As far as optimality goes, I know we have our sorting is O of n log n, which I don't think we can really improve. I and j are actually always going to coincide in the list, but we're never going to have more operations than there are items in the list. So that's O of n. So if we say like this is n log n, and this whole loop is O of n, and I don't do any sort of operations that are weird here. List indexing is O of 1. So we're going to say that this is an O of n log n algorithm. Seems pretty reasonable to me. There might be a more optimal solution.
Thanks so much for helping out, and hope that this was helpful. We are going to continue on more recruiting things if you have questions or if you're interested in it. Otherwise, like, subscribe, comment, and see you in the next video. Bye.